the real point to my coming up here was to just remind everyone who's doing a community survey or planning a community survey, or really using CFHT at all, but I'm really emphasizing the community survey aspect right now, that the CADC has been partnering with CFHT for a long time on providing archival services, but also data processing and data distribution services designed to work with teams of people working together to achieve their survey goals. And there's a lot of infrastructure that exists there, both service infrastructure and hardware infrastructure that you can make excellent use of in order to increase the impact of your science of your project. In fact, I think you go see a Danielle DeVos poster in the poster room, be reminded that half of CFHT or even more of their scientific impact comes from archival and catalog activities. So if you're doing your project, but you're not enabling others to find the outputs, so the very beautiful spectra that you produced or the catalogs of your measurements and such, you're reducing significantly the impact that your project could have for the telescope's scientific viability. This is just a reminder, basically, I think people are very familiar with CADC and CANFAR, of what we are. We're a data hosting, data processing facility set up by the National Research Council to provide equitable, fair access to data and to provide infrastructure for computing. We have a team of about 20-ish people who develop various services that we think enhance and enable better scientific use of data sets. And we have some astronomers who you're familiar with who help with various kinds of data processing. Some of you may not be aware that the CADC is going to be hosting the Canadian arm of the Square Kilometre Array Regional Center. This is an enormous undertaking in computing infrastructure for the world astronomy community, particularly focused, of course, on the SKA user. It is essentially the largest investment in computing infrastructure ever made in astronomy. Okay, so it's not just a small change, it's a step. It's an order of magnitude improvement or change in the observational data analysis capability of astronomy. And the impact of that isn't just, the radio astronomers now have more computing power, but there's all kinds of infrastructure and components and ideas of how to work together and to do data processing that are growing out of that activity. So the SK Regional Center is developing itself. It hopes to be operational sometime in 2027. And as it's moving along, right, it's building these things and these new capacities that even optical astronomers can make use of. In particular for the CADC, we're enhancing our service delivery on storage and compute quite significantly. We're currently somewhere around 3,000 cores of compute, a few tens of petabytes, of data storage. By the time the community surveys start, that will be 10,000 cores or maybe up to 17 or so, 50 petabytes of storage. A significant fraction of that, of course, is for the SK Regional Center project, but that capacity is there in a burstable kind of mode for a large chunk of the scientific community to use for projects at CFHT. So I asked the ChatGPT to show me a team of astronomers working together. So here you have a nice astronomy team. I'm not sure how they're playing hockey and doing astronomy at the same time, but there you go. But it does capture this idea, right? We work in these teams, and there's one part of the team is doing some observing, and another part of the team is doing some data processing. There's some people doing planning. I guess there are people on the bench who are waiting for that data so they can get to it and write some papers. Okay? Think of yourselves working on these teams. And so when you're doing that, you need these platforms, these processes to share. And if you're within one institution, you can kind of set that up in your institution. But we're thinking internationally across the whole broad spectrum of users within the community. And that's what we're trying to create with it. Well, I think we have created with the CADC CANFAR computing environment. Our motto in the CADC is always to try to solve the hard problem first, because once you solve that hard problem, then you can kind of build out the easier stuff. And we really believe that the being able to do proper group management, set up teams properly, have good authorization and access controls is a hard problem. It is one of the hardest problems to achieve in computer science, really. There's how do you name things, and then there's how do you do access control. So there's the group management system, the CADC. It follows the standard of the IVOA that we helped write. It provides access control so that you can store files in different parts of the system. You can have different kinds of compute, and access to that compute and storage is controlled through group memberships. And you can have some members of your group that are doing active data processing. You can have some members that are only reading stuff that comes out. You can have some that are building computing platforms for you and sharing them with others within the group. So a lot of the surveys are already doing this, right? The Classy survey works like this. CFS Unions is a huge user of this kind of capability. There's other, Citel has used a little bit of it as well. The Signals team, there's others that are doing stuff like this. So the whole point is, right, you come in, you create a group, you add members to this group. These user groups are used to control access to the computing and the storage. This all works inside of CADC's containerized computing environment. So one member of your group basically can offer software or set up software that does a particular kind of data processing, and then you can run that data processing at scale within the CADC on our Kubernetes cluster system using your customized container. Here's a technical outline of it for those of you who like workflow charts to understand where the different layers are. If you can absorb that very quickly, and then we can go have lunch. Okay, good. So that's what it looks like. The whole point is that basically there's a bunch of data that comes from computers. It runs through this containerized data processing system, and it shows up in the archive, and it shows up for your delivery. And the one thing I want to emphasize here is this piece in the middle where we're taking the metadata from your observations in order to make it findable. We want to do that not just for the stuff that comes from the telescope. We want to do that for the advanced data products that you're creating as part of these major surveys. Because then there's going to be this long-term, stable place where users will be able to find those advanced data products over a long term. And there's no work on your part. Once we push it into this archive, you don't have to maintain anything in order to make sure your survey is still visible. No, it's there. It's retrievable by others. So there's lots of different facilities stored in the system. Once you bring your users or you start working in there, you have pretty good access to all these different facilities that are storing their data within this archival system. Momogatik is on there, if that's a favorite of yours. There's LSST data in there. There's James Webb stuff, Subaru. There's all sorts of different facilities. So thanks very much.
Questions? The storage. So you have a quick question. So all the different surveys, there will be a way to get all the multi-wavelengths on Sky, some web interface, so that you can select different type of surveys in an area of the sky.
Right. So that you can select a particular area of the sky and get all the wavelengths that have been observed in that area, or you can select particular area and or particular wavelengths that you're interested in and see what areas have been covered in those wavelengths. There's overlaying features. And the one thing that, the more we have requests from users for a feature, can we have a way of doing this? Then it makes it easier to make those things available. So,
and for the computing power, so you mean that the community survey can use CPU, GPUs at the CADC directly? And
that's right. Yeah,
there's no limitation on the...
Well, there are limitations. Of course, there's a limited amount of resources, and so we have a quota system, and we try to create some reasonably fair allocation process for allocating this. But CFHT user surveys are already using a significant amount of computing in the data center to do this stuff. But I don't think it's widely known by everybody, so I try to let it know.
Okay, good.
Yeah, no, it's each so cool on that. The quick question, what evidence did you get on the CFHT, like connected to this? That's like the all hard buying.
Yeah. So the workflow from CFHT is so for Superior, they take some observations during the night. The raw observations flow to CADC. It's not quite enough data to make a good calibration, so those calibrated data stay at CFH. After the observing run is done, they do a processing. All the processed data are flowed to CFHT. And then actually, I think even once a semester, they reprocess everything once again to really tune it up. And they're processing it so CFHT is doing the processing. We're talking about then using CANFAR for that processing instead of doing it at CFH. the software, I believe, is written in Montreal. So it's a big kind of partnership activity between the three places to make it work. Right. So we don't provide right now a cross-matching service. It's something that gets asked about, and it's something that we think about. And no one has done it. There's cross-matching in that's been done by particular teams, and there is a large database server called that we call UCAT, which is for user catalogs, where people put their cross-matched catalogs into.
Thank you.
Central meeting for these fishing energies. That's when people that we love schools to service you can provide place. And most of the question is there will much less from maybe powers of which they're for voluntary. We need to we know and they must target if you can in for data or the targets. It's a way to store the data from situations which you can automatically just made some requests.
Right.
And give us a measurements with the journal things, photometry, for particular target with your interest.
So right now there are photometric catalogs available, but they're based completely on stacks. Stephen, you've not made single visit photometry available, have you? Yeah. It's not currently served. Yeah. So, but you can do there is photometry of stacks of data. For those who are looking for transient stuff, they would be more interested in the single epoch measurements. We haven't made those easily accessible at this time. We could, it just hasn't been a request. Yeah.
Other questions? No? Okay, so let's thanks again